So in the problem that's given, we have a radio station that's broadcasting at a frequency of 101.1 megahertz. What we know is that the speed of light is 3.00 times 10 to the 8th meters per second. Now that's important because the equation we're going to use to solve this is C is equal to lambda nu, where C is equal to the speed of light. Lambda is the wavelength, and then nu is the frequency. Now, our frequency here is expressed in megahertz, but we want to express it in just regular hertz, because if you read through, you would know that a hertz is equal to Hz, is what that is equal to a per second. That's the way I say it, which is 1 over seconds. And you see our meters per second with our light speed is what we want to convert that to. So a megahertz would be 10 to the 6th per seconds. And then our units would cancel out nicely. So if we convert this from megahertz over to hertz, we would get, let's see, let's do the math over here so we can see it. 101.1 megahertz. We want to get rid of megahertz, so we'll put megahertz on the bottom. And 1 megahertz is equal to 10 to the 6th hertz. You see? And so that would wind up being 1.011 times 10 to the 8th hertz. Okay? But a hertz is not the units we want to use. We want to use 1.011 times 10 to the 8th. A hertz is the same thing as a per second, or a second to the -1. Okay? So once we've got that converted and we've got it in hertz so we can compare it directly, we would just set up the equation using this C equals lambda nu. Our C is 3.00 times 10 to the 8th meters per second. That's the speed of light in a vacuum. And that is going to be equal to the wavelength times 1.011 times 10 to the 8th seconds to -1. And so we have to divide each side by that value for the frequency. 1.011 times 10 to the 8th. And this is just for the algebra to -1. And then this is 1.011 times 10 to the 8th seconds to -1. And then when we divide that out, we should get about 2.97 meters. Because when you have a per second divided by a per second, they cancel each other out. And so the unit you're left with is meters, and so that is equal to the wavelength.